Hello YouTube, RJ. Today we're going to talk about an antenna. I did a video on my hex beam that I got a lot of comments on, a number of emails, and hopefully helped out a few people on making some decisions there with a hex beam. But one of the common things I got is, okay, what do you do about from 20 to 6 meters hex beam great? What do you do like 40, 80? And other people said, hey, I see you have a wire antenna up. What are you using? What are you doing with it? And so I thought this video would be just talking about my wire antenna, the antenna I use for 40 meters and 80 meters or 75 meters. I spend quite a bit of time in the evenings on 75 meters. I've got a group I rag to with at night on 75 meters. And so I use that a lot, but I also do a lot of 40 meter QSOs and trying to pick up DX and such. So that's what this video is going to be about. We're going to cover my 80 meter full wave loop antenna, also known as a SkyLoop. Let me jump over the computer and let's start talking about the SkyLoop. First of all, let's talk about the name. It's been called many things, but in QST magazine back in November 1985, Dave Fisher did an article where he called it the Loop Skywire. I've heard it called many things too, but commonly I hear it called the SkyLoop. And all it really is, it's a horizontal loop of wire cut for the band that you want to use it on, the lowest frequency you want to use it on. And so let's take a look at how it actually lays out. Okay, this is a very simple rendering of what I've got. Understand this loop is not vertical as it appears in this image. It's just done that way so you can see the four corners. It's horizontal, so that you would have two additional trees way farther away that the top corners would be connected to. But basically, I'm feeding in the middle. Now, there's a number of ways to feed this. There's a number of ways to design it, and they have implications. And in my particular case, this is my preferred setup. I feed it from a midpoint into 450 ohm window line. Now, you can use coax, but depending on your use case, you may find that you're much better off the window line. And the reason is because if you want this thing to be able to be used on multiple bands, you really probably want to run with the window line or ladder line if you really want to go all out, because of the mismatches with your SWR that you might need to tune out. Your losses are going to be staggeringly smaller with the higher ohm window line or ladder line. But anyway, one of the things about these loops is they do not come in at 50 ohm impedance. And so one of the things that really helps is they tend to typically be in the 200 ohm range. So a 4-to-1 balun is very helpful at the end of your window line. The other thing it does is by using one of the 4-to-1 baluns that goes from balance to unbalance, in other words, from your window line to your coax, you can use a very short piece of coax coming in the shack and not have to worry about having issues with your window line or ladder line be close to metal objects, affecting it and causing it to leak RF. It's easier to feed and deal with the coax coming in. Very flexible, very handy, and as you'll see in my upcoming images, it also helps me with like lightning protection and stuff. So let's take a few looks at the actual, instead of this illustration, the actual work on my antenna. Okay, what we have here is the feed point. My tower is in the center of the west side of my loop. You can see the window line coming up there, and this is one of these devices that grabs your window line and gives you a points to hook your antenna wire. And you can see the antenna is actually made up of 14 gauge THHN house wire. And then the rope goes up to the top of the tower for support. So this is my feed point. There's really nothing here other than just that. Here you can see one of the corners. Every corner of my rectangle loop has a pulley. You're looking at a pulley that the antenna wire runs through to let it move freely. And then if you pay real close attention, from the pulley just a short way towards the tree, you'll see what looks like a knot or something there. And that is actually what that is there is paracord from the actual pulley over to that point to isolate the antenna. And then what you're tied to there is actually stainless cable with plastic coating, sort of like what you use on a dog runner. And the reason for that is very, very simple, is because all the way through the tree branches until it turns and comes down towards the bottom of the tree, that you'll see in a minute. And as I come down through the tree where I'm no longer going to be rubbing on branches or so, this metal stainless plastic covered cable stops, and then a paracord takes off again and runs down to what I'm going to show you in a minute. And I'll explain that when we're looking at that picture a little better. Okay, what we have here is my tie off at the tree. You can see that I'm anchored into a tree at the bottom. I've got a screen door spring that's hooked to a rope slack device that allows me to adjust very easily. By just literally pulling the rope, I can tighten it and then it locks. And that paracord rope that you see there runs up into the tree a little ways, but before it gets up into branches where it's going to rub and such, it's tied to the steel cable, the plastic covered steel cable. And so what this does for me is it gives me a steel cable with plastic on it running through all the branches and back out of the tree, so that I'm not rubbing on a rope to break. And also I have lots of squirrels and they love to chew cords and ropes. They'll choose any rope or cord you put up in the tree. And so they don't seem to care about it being down here at the bottom or sticking out away from the tree, but they seem to think that if you put it in their tree, it shouldn't be there or something, and they love to chew on it. So this keeps me from having to replace ropes continuously. That steel cable they can't chew through, the tree doesn't rub through, and that works great. The actual spring gives me give, keeps my antenna up there a ton. I have this at each tree, and it gives a lot of give. So as the trees sway in strong storms and hurricanes, this allows it to stretch at each tree and give and keep the tension just fairly even, and not pull the wire tight and break things. So it works very, very well. As you can imagine, here in Central Florida, we have lots of thunderstorms, high winds. It's not uncommon for us to see 60 mile per hour, 70 mile per hour winds. That's a common thing during the summer and in thunderstorms. And of course, we get hurricanes where we get over 100 miles per hour. So this helps out greatly there. So that's what I do for that. Okay, here's my coax and ladder line running under the deck into the shack. And I just hold the window line off with some PVC in the ground and then tie wrap it to it. It keeps it away from conducting things and from blowing around and such. And you can notice there's a little twist continuously to it to help with wind and keep it from flexing as much and such. So here I'll show you what it goes up to at that point. Okay, here you can see my 4-to-1 Palomar balun at the bottom here. And you can see I've got it waterproofed quite well, and I've got a bunch of ferrite beads around it to help with any common mode rejection where it comes out as coax up into my outside receptacle box that is my feed into the ham shack. You'll also notice on the back behind it, you'll see another coax and the rotor control cable, and you can also make out my ground wire there. Now this is what's inside my feed tray. You can see there's 2 lightning suppressors, one for each of the coax that goes in the house. I'm using RG213 for coax, and you get a little better picture there. And you can see I've got a grounding bar that's grounded. I've got quite a grounding rod in directly below that. And I've got a grounding wire, as you see, going into the shack. And so that's what's inside the box. Everything's foamed up to keep the critters out. That's kind of it. From there, this runs into my antenna tuner and into my equipment and such. Now, in this illustration, the person is using coax cable to feed it instead of window line. But this is basically the loop that I have. It's roughly a quarter wavelength on each side. It's not perfect. It's a little oblong, but it's basically this. And my 80 meter is around 200. It's pretty close to those measurements. I think I came out 267 feet, if I remember correctly. It all depends on where you want to center your frequency, on what your lowest frequency band you want to operate is. That is the build of the antenna, and I'm going to show you some stuff to back up whether they work or not at this point. Okay, now I want to talk about the performance of the loop. Why would you want to consider this antenna? Well, there's quite a few good reasons. Now, before we get into that, I want to dispel some things. You're going to hear from a lot of hams that this antenna is what's called a cloud burner. It shoots all the energy straight up. Nothing goes out for DX. They don't do DX. They're just medium range to local communication antennas, and they do that well, but you can't DX with them. They don't work for long distance communications because you don't have a low angle takeoff. That the loop itself focuses the energy straight up, and that's what they're good for. And I'm not going to disagree that they have a tendency to kind of work that way, but it is not to the level that most hams claim they are. It does have a lot to do with how close you are to the ground. My antenna is about 40 feet up, which is typically what I tell people you need to be. As you get closer, there is ground effect that will tend to push your energy up. It's the same whether you're using a dipole, whether you're using a horizontal loop, whether you're using a bazooka, a double bazooka, an inverted V. It doesn't matter. This is effects. The ground looks like a mirror to your RF, and it tends to bounce off and tends to distort your energy upwards. And we're going to see that because we're going to pull up Easy Nick, and I'm going to show you some patterns and stuff to kind of show you what I'm talking about. The truth is that I like loop antennas. Full wave loop antenna is fantastic. It can be used on multiple bands. I'm going to show you the limitations to that in a minute. It can be used on multiple bands. They can DX. I'm going to show you that. I'm going to prove you. I'm pulling my logbook up and just show you just a few of the 40 meters contacts I've made on that antenna and let y'all be the judge. But what you'll find about these loops are they're quiet. They're very quiet antennas. There is a noticeable difference between over the years at times I had multiple different antennas up that I could switch between, and it was a noticeable difference with the loop. The SkyLoop is absolutely quieter. It has a tendency to cancel out atmospheric noise and other RF aggravations. And so I really love the loop. I've tried a lot of antennas. I always come back to these loops. And while the hex beam is absolutely the answer, in my opinion, for 20 meters through 6, you're not going to build a 80-meter hex beam. Wouldn't be practical. So I have to have something to fill in that 40 and 80, and that's the only thing I use this antenna for. I find they're very good if you're only going to pull 2 bands out. I'm going to show you in a minute on Easy Nick. I'm going to show you why they're not as great. While they can be used all the way, you can use this antenna all the way to 10 meters with the tuner, especially using the window line or ladder line. There's some effects you need to be aware of, and I'm going to show those in just a moment. Let me jump over. First thing I'm going to do is I'm going to show the proof that these things can DX. I'm going to show you I told my logging software to show me 40 meter contacts. Of course, it gave me the first ones, and I found them interesting because those are the lower power ones that I was using my little homebrew radio on with low power. And I'll show you just a little snapshot of those, and you tell me whether this antenna performs well enough for you. So let me jump back on the computer. Okay, here's the little snapshot of some 40 meter contacts off my logging software. Now, not everything I do is on here because I started using this a couple years ago, and stuff prior to that isn't on here. But this is all 40 meter stuff. I told it to give me just 40 meter. This is just one screen. What I want you to notice, a number of them I don't have confirmations on, but quite a few of them I do through LOTW. But if you notice, for example, like there's the Bulgaria, the second one down. I was using 14 watts off my little homebrew radio because that's all it could put out. And you can see, I got a 5.5 from Bulgaria. Come on down and let's look at, here's Portugal. I got a 4.5 with 14 watts to Portugal there. I got, let's go on down and look at, say, there's Germany. Now, I was using 85 watts on that contact. I had, at that point, I'd built a little 100 watt, supposed to be a 100 watt amplifier. I only got about 85 out of it. There's a Federal Republic of Germany. I got a 5.9. There's Portugal. I got a 5.9 with 85 watts. There's Slovenia. What is that? 5,000 miles from me at least, probably more than that. 85 watts. Got a 5.9 contact out of that. That's just a tiny little part of my logbook. Massive amounts of very long distance QSOs on 40 meters using this antenna. So the idea that they can't do long distance is look at how low a power I was working some of this stuff on. That's not true. These antennas work very, very well. Now let's take a look at some technical information on the pattern of the antennas. So give me a second to be an easy nick up for you. Okay, let's talk about the patterns of this antenna. What we've got here, we've got EasyNIC 7.0, the antenna analyzing system, and I programmed in my loop. Let's take a look at it. Here's the antenna. Okay, here's my loop. It's 40 feet in the air. Here's the feed point right here in the middle of segment 2. And we're going to take a look at what this thing looks like. So right now, I'm using it on 3903 megahertz, 75 meters. And if I plot it, this is what you're going to see. Not a perfect spear, but a quite good looking spear where the your output and reception in your different directions are fairly even, not perfect, but fairly even looking. And if we go in and we turn on the 2D plot here, and let's take a look at, go down to 45 degrees. That means that we're shooting straight out 0 degrees off the antenna. And we can see that from the best output we can get from the pattern, we're down about 3-4 dB. So the antenna can do 4 dB better at some other angle. So let's go up. We want to be looking at that magic, everybody wants 7 degrees. Here's 5 degrees. Okay. At that, we're about 2.5 away from our best output. We go up to another 5. So now we're 10 degrees above the horizon. We're not down much at all. We've actually got 4.05 dBi. So, as far as not putting radiated energy out at low angles, that's not really true with these antennas. Now, is it true that they shoot energy upwards effectively? Yes, they do. In fact, the gain is 7.1 straight up. And that is its strongest signal is upwards. But as far as this belief that it's dramatically different, we're 7.1 dBi. Let's come down to a more reasonable angle. And we're still 5 dBi right there. So, the antenna will work for DX. It's not limited to just shooting all your energy straight up. That's not true at all. But so here's our pattern. This is 75 meters. Now, what about using it on other bands? That's the real thing I want to take a look at here. We're going to change. Let's go to 40 meters. And I'm going to do that by bringing this frequency up. I'm going to tell I want to go to 14.150, kind of in the middle of the 7 meter band, or the 40 meter band. I'm sorry, not 14, 7.150, 40 meter band. And I'm not going to rescale. We don't want the antenna to change. We're going to be using the same antenna. If I rescale, it'll change it to the links needed to be perfect on this. We're going to stay with our current antenna. So, okay. Now, let's take a look at the plot now. And I think you'll notice right off the bat that you're getting some different stuff. Look at the distortions. And so what happens is when you use these antennas on resonant bands, you get some effects on the pattern that's radiated. You can see here you're going to receive and transmit this way, this way, this way stronger than this way. You're going to receive and transmit to stations in these directions weaker. That's what it's showing you here. Still not horrible, not a horrible antenna on 40 meters. What would happen if I tried to use it somewhere else? Well, again, that's why I like to use them on like 2 bands that are together, 80 and 40. Because if I take this and I say, okay, let's take it from here and let's go up to 20 meters, 14.150. If I do this, let's look at what happens to the plot now. Now it's getting really out there. You're going to start having some strange patterns. Look at the pattern of this thing, okay? It's strongest in this direction, and this direction. Weaker in here, really weak on these sides. You get some erratic patterns. And this antenna literally can be used all the way to 30 megahertz. People do it and claim it's great, but they need to understand the reason they're getting these strong, oh man, look at the signal I got. It's because that person was in a certain direction and you're getting a directionality of your antenna. Take a look at what happens if I do this. Wow. Like I always tell my buddies on 75, you know, it turns into a flower after a while. And so you can see that, you know, if you're talking to somebody in this direction or this direction, you might get some great signals, man, fantastic. But somebody in between those two people, that's not very far away, you might not be able to hear because you've got a massive null here. And so you've got a very unpredictable pattern of radiation. It's just unpredictable. You can't reliably use an antenna with patterns like this. That's why you really want to kind of keep these things down in close to the frequency they were cut for. Now, if you want to use this antenna on 20 meters, just cut the length for 20 meters. And then you get the same, just as you've got a distortion here. If I put back our original frequency, you know, you've got this clean pattern. If you cut the length for 20 meters, you'll get this pattern at 20 meters. If you cut it for 10 meters, you'll get this pattern at 10 meters. It's only when you're trying to use them on resonant bands, you're not using them for the band they were cut for, that you start seeing these pattern changes. So anyway, hopefully that explains how this works out. I hope that you found this informative, helpful. So I appreciate you hanging in here. If you've got any questions about any of this, you know, maybe I've missed something I should have brought up, feel free to put it in the comments. I'll be happy to try to answer any questions you got. And who knows, it may lead to another video. So thanks for hanging in here. I really would appreciate it if you enjoyed the video. You'd hit like and subscribe if you haven't. But most of all, I hope to see you in my next video.